This video demonstrates the procedural steps involved in the hydration of 1-hexene using 85% sulfuric acid. As you view this video, you should follow along with the written procedure. In a 10 milliliter round bottom flask, you'll place 2 milliliters of 84 to 85% sulfuric acid, 1 milliliter of 1-hexene, and a small magnetic stirring bar. You'll then loosely cork the flask, securely clamp it to a ring stand or metal rod in your fume hood, and then use a magnetic stirring motor to stir it vigorously for 15 minutes. At the start, the reaction mixture will appear cloudy, but after 8 to 10 minutes, it will become clear in appearance. Continue to vigorously stir the solution until a total of 15 minutes has passed from the start of the reaction. At this point, you'll carefully add 4 milliliters of water to the flask, recork the flask, and then vigorously stir the resulting cloudy mixture for another 15 minutes. Leaving the stirring bar behind, you'll then transfer the entire solution to a large-sized, that is 16 millimeter by 125 millimeter disposable test tube, and it will most likely appear as shown here. You'll then rinse the 10 milliliter round bottom reaction flask with 4 milliliters of ether and transfer the rinse to the test tube. 2 distinct layers will be seen in the tube, the upper one being ether and the lower one being water. Next, you'll perform a mini extraction of the lower water layer as demonstrated here. Use a pipette with a rubber bulb to draw up some of the lower layer and then vigorously force it down through the upper layer. Do this approximately 15 times. This agitating motion will thoroughly mix the 2 layers in the test tube together. This mini extraction is a small version of a typical large-scale ether water extraction using your separatory funnel, where ether-soluble components like your hexanol product go into the ether layer and water-soluble components remain in the water layer, like sulfuric acid, which you want to remove away from your product. Shortly after you stop mixing the layers, they'll separate again into an upper ether layer and a lower water layer. By looking carefully, you'll see the point where the 2 layers meet. Now that the ether layer containing your product has separated from the water layer, you want to physically remove the ether layer to a new large-sized test tube using a pipette and rubber bulb. When transferring, keep the 2 tubes close together to avoid spills during transfer. Be careful not to transfer any of the lower acidic water layer along with the ether layer. To make sure of this, leave a very small amount of the upper ether layer behind with the water layer. Safely set aside the tube with the ether layer so that it doesn't spill. And set aside the large tube with the water layer for disposal later on at the end of the experiment. Here you can clearly see the small amount of the upper ether layer left untransferred. The ether layer that you transferred to another test tube and set aside must now be extracted, or as sometimes said, washed, with 10% aqueous NaOH to neutralize any trace of sulfuric acid present in the ether layer. You'll add 2 milliliters of 10% aqueous NaOH to the ether layer and perform a mini extraction in the same manner as before by using a pipette and rubber bulb to draw up some of the lower water layer and then vigorously forcing it down through the upper ether layer. And you'll repeat this action about 15 times. Then use the pipette and rubber bulb to draw up a very small amount of the lower water layer and test it with red litmus paper. It should be basic at this point, as shown here, but if not, you can repeat the NaOH extraction until the aqueous layer is basic to litmus paper. Now the acid-free ether layer containing your reaction product mixture should be transferred away from the lower aqueous layer into a medium-sized, that is 13 mm by 100 mm, disposable test tube using a pipette and rubber bulb. Leave behind a very small amount of the upper layer in the test tube to avoid accidentally transferring some of the lower water layer. Once again, keep the two tubes close together during the transfer to avoid accidental spills. Momentarily set aside in a safe location the test tube containing the ether layer. You can see here a small amount of upper ether layer that was left behind with the lower water layer. Set aside this tube containing the aqueous layer for disposal at the end of the experiment. To remove any traces of residual water that is present in the ether layer, you'll treat the ether layer with a drying agent, in this case anhydrous sodium sulfate. Briefly agitate the contents of the tube, cork the tube, and then stand it upright in a safe location. It's this solution that you will analyze by TLC according to the instructions in the written procedure. You will perform TLC co-spotting of this ether solution versus one of the expected hexanol isomers. The technique of TLC co-spotting is described in a separate video.